NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
This is an artist's concept of a lifting body. It is believed these wingless craft hold great promise as future reusable space shuttles, able to fly a mission, re-enter the Earth's atmosphere, and land like an airplane. Tests are being conducted jointly with the Air Force at NASA's Flight Research Center in California. Shown here is the HL-10, one of several lifting body designs just before being dropped from the wing of a B-52. The drop is made some 45,000 feet above the Mojave Desert. Shortly after launch, the pilot ignites a 4-barreled rocket engine and the lifting body soars to almost 80,000 feet at better than 1,000 miles per hour to simulate a return from space. NASA began work on the lifting body concept about 12 years ago. Starting with drawings and then models of a cone cut in half, engineers blunted the nose of the cone to help withstand the searing heat of re-entry. Fins and control surfaces were added to make the craft stable and maneuverable. Although at present the flights last only a few minutes, they are significant, for they are proving that flight without wings is possible. The stubby-looking lifting bodies are the forerunners of vehicles that may one day be hurled by rocket into space, perform their mission, and then land on Earth like an airplane. This 106-foot-high Delta rocket recently was used to launch another in the series of orbiting solar observatories, OSO-6. The latest Sun Watcher is now in a near-circular orbit some 350 miles above the Earth. In this distortion-free position, it can be aimed with accuracy at thousands of points on the Sun to study solar flares and sunspots close up. Shown here before launch, this is what the 640-pound OSO looks like. It is made up of two major sections. The upper part is a semicircular sail with 2 experiments and always faces the sun. The lower half is called the wheel. Carried here are the scanning experiments and basic support equipment for the spacecraft. Because OSO-6 was launched during one of the times of greatest solar activity, it is possible that the information it returns will give us the best understanding so far about solar radiation storms that affect the Earth's environment. To track and measure the distances to satellites as they travel through space, NASA uses lasers. After predicting where the spacecraft will be at any given time, telescope-mounted lasers swing into position, and their pulses of light lock on and track the orbiting craft aided by computers. Retroreflectors like these mounted on the spacecraft bounce the light back, and the satellite's position can be precisely determined and the distance measured, simply by measuring the time it takes the beam to go to the satellite and return. By tracking spacecraft using laser systems, scientists have found they can measure the distance to the spacecraft within 3 or 4 feet. This same technique can also be used to make precise measurements between locations here on Earth, even across oceans, with the same degree of accuracy.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.